Hi, welcome to this video demonstration of binary classifier AveragedPerceptron algorithm. In this project, we are going to basically create a binary classifier to classify restaurant reviews from Yelp into positive and negative reviews, and therefore the outcome is going to be binary. That's why we are choosing a binary classifier called AveragedPerceptron. So let's look at the project structure. It's very similar to the project structures you have seen in earlier chapters, since we are using the same training data set called Yelp label.csv. So in this case, we have dependencies. Under dependencies, we have Microsoft ML 1.1 library already installed as part of this solution. First, we need to update this library because now the current version is 1.2.0. So let's do that first. So we right click, select manage NuGet packages, and select browse, and then we type ML for machine learning, and we see Microsoft ML. And you can see that the current version is 1.2.0 and our current version is 1.1. So if you find that the project solution is version 1.1 or 1.2 and they have released a higher version, say 1.4, 1.5, you can easily update that. So in this case, all you have to do is basically click the update button and click OK. And the updated package will be automatically installed. So let's check for it right here. As you can see under NuGet, we see Microsoft ML 1.2 has already been installed. So that's the first step. Let's go back to program.cs. So now, just like the previous chapters, you need to create sentiment input.data input.data.cs input data model, and sentiment prediction output.cs put data model class. And as you can see, it's the same class that we are using here as well, since the training data set remains the same, Yelp labeled Yelp underscore labeled.csv file. So here again we have using Microsoft ML.data, we import this library and we create this class called sentiment input data, and there's two properties, public string sentiment text and public boolean sentiment, and you have already seen that as part of the previous chapters, so I'm not going to spend too much time on it right now. Same, we see that in sentiment prediction output class, which is a subclass of sentiment input data, we have imported Microsoft ML.data, and we have three properties you have seen before: public boolean prediction get set, public float probability get set, and public float score get set. So this is also something that you've seen earlier as well. Our training data set is Yelp underscore label.csv. Again, we have the labeled text. On the left hand side, the first column represents reviews, and the second column basically represents 1 and 0, 1 for positive review and 0 for negative review. And of course, you have to make sure that the copy to output directory is a chosen copy always. So having done that, so you have imported the library, and you need to create these two classes. So let's go to program.cs. Under program.cs, you have to make sure that you have using system.io imported here. Then you import the Microsoft.ml libraries, Microsoft.ml, ml.data, Microsoft ML.trainers, and Microsoft ML.transforms. Then you need to import using static Microsoft ML.data operations catalog. And next we move to class program. And in step 1, we declare two paths. One is for training data path, static read-only string training data path, path.combine environment.current directory, Yelp label.csv. So that's our training data file. And the second path we declare is for saving the trained machine learning model for later use for developing intelligent applications. We have static read-only string model path, path.combine environment.current directory model.zip. Having done that, we move into static void main method, and here we create classify sentiment or declare classify sentiment method. And outside of main method, we specify the classify sentiment method details here. Public static void classify sentiment. In step 2, we instantiate ML context object. As I said earlier, ML context object is the most critical object that you need for machine learning. So ML context equals new ML context. Then in step 3, we create a data view object using ML context.data to load the training dataset. So we do that here, data view, training data view, ML context.data.load from text file. We provide sentiment input data, and then as argument we provide training data path that we created here in step 1. That becomes an argument over here as part of load text file method. Has header is false because we don't have any header in the training data file, and separator character is comma because that's because this is a .csv file. Step 4, we split the training data automatically into 80% for training and 20% for evaluation. So we use train test data by using ML context.data.train test split, and we provide training data view as part of the argument and test fraction 0.2. Training data view we declared here, instantiated here as part of step 3, which now becomes an argument that we pass to train test split, and we specify test fraction 2 that is 20%, and so it will split the training data set 80% for training and 20% for evaluation. Step 5, we create the data preparation pipeline. We call that we use ML context or transforms.text. We are using text transformation because our data is text. .featureize text, output column is going to be features, input column name of sentiment input data .sentiment text. You have already seen this in the previous chapters. It's basically the same set of concepts you're using here as well. Step 6, we create the AveragedPerceptron trainer data preparation pipeline.append method, and then we pass ML context.binary classification.trainers.AveragedPerceptron, and then we pass label column name label and feature column name features that we get as output from data preparation pipeline object, and we provide that input here. And then in step 6, continuing step 6, the var model, that's our trained machine learning model. AveragedPerceptron trainer that we declared instantiated here .fit, and we pass train test data .train set. So we are training the AveragedPerceptron algorithm, and you're passing the training set, which is 80% of the data. In step 7, we do evaluation and assessment of the trained machine learning model. We use data view, predictions for evaluation data view, model.transform, train test data.test set. Here we are using test set data, that is 20% of the training data set will be used for evaluating the model. We create this data view object. Step 8, we create the matrix here, instantiate the matrix using ML context.binary classification.evaluate non-calibrated. We are using a non-calibrated method over here, which basically takes in prediction for evaluation data view that we created or instantiated in step 7. We pass this here as an argument. Label column name label, score column name score, and predicted label column name predicted label. So these are the arguments that are taken by evaluate non-calibrated method of the binary classification. Then we move to step 9, where we send the output to the console. We have binary classification trainer algorithm AveragedPerceptron, and the model evaluation metrics here are accuracy, F1 score, area under ROC curve, area under precision recall curve. This one does not provide any log loss or log loss reduction metrics, so we don't make use of them. We do, however, get confusion metrics, positive precision, positive recall, negative precision, negative recall. And then in step 10, we create a new sentence, as you've seen before, using sentiment input data, and we create sample sentiment text. I love this restaurant. And in step 11, we create the prediction function. So prediction function is created using mlcontext.model.create a prediction engine. We provide the sentiment input data model and sentiment prediction output data model. And then we pass the trained machine learning model that we instantiated in step 6. So that becomes an argument here. Step 12, you use prediction function to predict the sentiment. So the prediction result is obtained by using prediction function.predict method, and we basically pass the sample sentiment text that we created here in step 10 as argument here in step 12. Then we have some console.writeLine statements here to get the output. So we have console.writeLine prediction sentence, meaning we want to see what sentence we're predicting as part of output. So we have prediction result or sentiment text. Then we have predicted sentiment. So in this case, the output is going to be binary, either 0 or 1, but we want to see corresponding 1 for positive and 0 for negative. And then we have the prediction result probability. Once we have done that, in step 14, we save the machine learning model using a file stream object. We pass the model path, file mode.create, file access write, and file share write. We define model path in the beginning of the program. And then we use mlcontext.model.save, and we pass model, training data view.schema, and file stream object. And that will help us save the model. So that's the program, and as you can see, many of these programs are very similar because we are using the same training data set, and at the same time, significant credit goes to excellent developers and designers of Microsoft.ml package, that they have made this extremely simple for creating machine learning models, and they have created nice classes and methods that are fairly easy to understand and can be used with a few lines of code. So having said that, let's run the program to see the output. So we are going to click here. As you can see, the output here, we have the binary classification trainer algorithm AveragedPerceptron. The model quality basically shows accuracy 76%, F1 score 74%, area under ROC curve 83%, precision and recall 80%, and the confusion table basically shows precision here and recall over here, and positive precision and then positive recall, negative precision, negative recall. And these are the different performance metrics that we already defined as part of the program. And then we have the sentence that you wanted to classify, which is I love this restaurant, and it has been predicted positive, meaning it's a correct prediction. And we have already saved the model. So you can see again that given the same data set, each of the algorithm shows a slightly different level of performance, and you can pick and choose the specific training algorithm depending upon your data and the level of accuracy you want. Thanks for watching.